Okay, kamusta o welcome back to our discussion, no? And I'll be discussing another method of solving a first degree DE. So if we have to recall, now this is the fourth method already. Now, so upon solving, now your equation as exact, no? And you notice that the DE is inexact, no? So this is how you proceed, no? So when you test for the exactness, no, of the DE, then the partial derivative of the coefficient of your dx, no, is not equal to the partial derivative of the coefficient of dy with respect to x when it is differentiated, no? Now, this is how we're going to proceed. We have to look for an expression, and that expression will be multiplied to the original dA, which will convert the dA into an exact dA. Now, that expression is what is termed as an integrating factor. Now, how to get this integrating factor? Okay, so first case, no? The integrating factor can be obtained, no? By taking the difference of these two partial derivative, no? You subtract them, and if the result is divided by n is the coefficient of dy, and you were able to produce a function that is purely x, then the if, we denote that with v, is equal to, so this is the formula, an exponential of the integral of the purely x function, no? So you integrate that with x, no? Now, this is your if. Okay, now another case is, when you take the difference of the two partial derivative and divide that with m, and the resulting function is a purely y function, then this is the formula to find the if. Okay, so we have the exponential of the opposite of the gist of y you solved, no? So integrate that with variable y. Okay? Now, the third case is when your if is not purely x nor purely y, but a product of xy. Okay, so when you have an if which is a product of x to an unknown exponent m, y to an unknown power of n, then we have to solve for m and n, no? So using this equation below. Okay, so we have the difference of the two partial derivative is equated to the product of the power of your x multiplied with the coefficient of the dy divided by x, subtracted with the product of the power of your y, the unknown value n, no, multiplied with the coefficient of your dx, which is m, and divide that with y. Okay, so how to use this three conditions in finding the integrating factor. Now, when we are given a dA like this, now, so we have this as the given. So I have to check for the exactness. I have to determine what is m from the given, and I have to determine what is n. Okay, so my m is x squared plus y squared plus 1, and my n is the product of x and the quantity x minus 2y. So, taking the product, so we have x squared minus 2xy. Okay? Now, differentiating your m partially with respect to what variable? Y. Diba? Okay, the derivative of x, this is considered as a constant term, so this is 0. So, derivative of y squared is 2y. Again, this is a constant. So, the partial derivative of m with respect to y is just 2y. Okay? Now, what is the partial derivative of n with respect to x? X squared becomes 2x. The 2xy, the derivative of x with respect to x is 1. So, what is left as the derivative in the second term is just 2y. But if you compare the two results, obviously, the two are not equal. Thus, I can conclude that these two partial derivatives, no, actually lead us into a conclusion that the dA given is inexact. So if that's the case, no, then I can subtract the difference, the result of the two partial derivative. So we have the partial derivative of m with respect to y is subtracted with the partial derivative of n with respect to x, when the results are, I have 2y minus the 2x minus 2y. No? So we have 4y if you combine, and minus 2x. Now, I notice that between the terms, there is a common factor of 2. So, to start with the positive x term, then I include the negative 2 in the factoring, or the negative, no? So, we have minus 2, remove, so I can start with an x term, so x minus 2y. Okay, now, you can easily determine what coefficient will be used as a divisor, whether it is m or is it n. So, you just compare with the coefficient here, no? So, if I have x minus 2y, then that belongs to y, no? In order that the result can be purely x. So if I'm going to use m as my divisor, then I cannot produce a purely y function, no? So I can try with the first case. Actually, I'll try because I'm already certain that I can produce a function of x, no? By looking on the given, no? Okay, now this is how it is divided. So the difference of the two partial derivative, which is the minus 2x minus 2y, is divided by n. And my n is the product of x and x minus 2y. So it's good to use the factored form that we can easily remove, no, the expression which is containing xy. And what is left is the function that is purely x. Okay? And this is the expected result. The function must be purely x. If you arrive with a constant and we are expecting a function in x, that constant will be considered as a function in x. Just in case, no, when you divide and the resulting expression, a function is just a constant, then we are expecting that the result is a function of x, no? So treat it as a function in x. Now I can proceed with the if. So for the if, we have a formula. So our if is equal to the exponential of the f of x, then the x, no? So we have an exponential. Minus 2 is a constant factor, so I can have the minus 2. So what is left when I'm going to integrate is the dx over x. No? So exponential of minus 2 by formula, that's ln x. To simplify further, because this is e, no? And I have ln, so I make my 2 as a power of x. No? So ako na ibutang dire para I can simplify further. Okay, so this is exponential minus 2 ln x. To further simplify, then this constant factor is taken as a power of x, no? So that this is now simplified being the x to power minus 2. Or that's equivalent to 1 over x squared. Now, after knowing the if, no, that function or that expression will be multiplied to the given dA, and our purpose there is to convert the dA into an exact dA. Okay, so this is the original. Then, akong i-multiply ang if nga itong na-identify. So, by distribution, we have the terms, resulting terms of my coefficient. No? So, we have this 1. This is the result. Okay? So with this, no, so I come up with a new equation. Now, this equation, if this is a correct integrating factor, so kinesia will actually produce an exact differential equation. So, how to know that? Then we can retest for the exactness. So, what is my m? My m is this coefficient. Okay? And my n is the 1 minus 2x to power minus 1y. Differentiating this function partially. M differentiated with respect to y. This is 0. X squared, x to power minus 2 is a constant factor. So, I can differentiate my y squared. That's 2y. This is a constant. No? So, the result of this is 2x to power minus 2y. So, I'll be expecting that my n, if differentiated also, partially with respect to x, will produce the same result, no? Muhatag siya og the same result with the previous. Or else, dili na ko siya makonsider as exact. So, there is something wrong when the if was evaluated. Okay? So, ingin. So, differentiating your n partially with respect to what variable? X. Constant is 0, becomes 0. So, under power rule, so, the minus 2y, by the way, is a constant factor, no? So, under power rule, so, x to power minus 1, so this is my n. Then, I can subtract my power minus 1 with another 1, negative 1, no? So, I can have the minus 2 as new power. Okay, so this is equivalent to 2, x to power minus 2, they are the same, then we have y. So, I can conclude that the new differential equation is now exact. So, I can proceed finding or solving for f. No? So, this is how to solve for f. And the new equation, no, being transformed to exact DE already. Okay, so, I can integrate my first term partially with respect to x. I'll be adding the constant of integration containing also a function in y. Okay, so what are the terms coming from the coefficient of dx? We have this one. 1 plus x to power minus 2 y squared plus x to power minus 2. So, integrate partially with respect to x. X for 1. Kine, y squared is a constant. So, I'll be adding 1. No? So, this is x to power minus 1 over the n plus 1 form. No? So, this is the integral of my second term. Okay? Then, this one, the same rule. Okay? plus the unknown function. I may rewrite, no? To have an expression to contain a positive power is equivalent x minus, this is a negative term, okay, y squared over x, and this is also minus 1 over x, plus the unknown function in y. By the way, this is already an answer if this is complete with the value or the unknown function y. But I don't have the unknown function y yet, no? So, I can look for this unknown function by taking the integral of my second term, no? When I'm going to integrate my dy term, no, partially with respect to y. So, my integrands are 1 minus 2x to power minus 1 y. Okay, integrate partially with y. This is y from 1. Power rule, y squared over 2, so I can eliminate my 2. Then, unknown function and purely x, no, is added. Okay, so my terms are y minus y squared over x. So, this is a function involving xy. So, dapat this term will also be present in my first possible answer, which is kini. Okay, plus the unknown function in x. So, second possible answer. I mark this as a sub 2. Now, the a sub 1 has more number of terms compared to the a sub 2. So, this will be naadire ang atong mga terms sa atong solution kalagmitan. Okay, and what is needed here is only to include the g sub y. Okay, so, using my a sub 1, I have to collect all the terms. Okay, so what are the terms coming from the a sub 1? So we have this all, correct? Okay, a copy. So I'll be looking for the g sub y. The g sub y, I have to consider the a sub 2 and look for a term purely y if it exists. And this is the purely y function. So I can introduce the g sub y with y. But my f is equal to c. So ang imong kuhaon sa ito is only the term that is purely y. Okay, so we have f being equal to c. So, if this is my f, so I can equate that to c. Okay, so this is your general solution, or I can remove my denominator by multiplying with x every term. So, this is your answer. Now, if ever you consider your ito in finding your f, no, or in determining your f, so you can list down the terms from ito, then you can look for a term which are actually purely x, which are kining duha. So, mas maayo ari ka sa equation nga mas daghan og term kay posible kana siya gamay ra kag dugangan. Okay? So, second problem. So, in number 2, this is the given. So, I try to identify my m. This is my m. I write that in a product form by distributing my y. And my n, ako sang i-distribute akong x. So, these are the terms of my coefficient of the dy. I have to test for the exactness, differentiating my m and n partially with respect to, okay, sa m with respect to y. So, this becomes 1, so there's 2x. This is minus 2y, correct? This is 1. Okay? Differentiate your n partially with respect to x. Okay, so this is 6x, eh? With respect to x, this becomes 1. So, 4y na lang mabilin. And we have 3. Now, the two are not equal, so this is inexact. So, if inexact, just subtract these two partial derivative. No? So, we have the partial derivative of m with respect to y, subtracted the partial derivative of n with respect to x. Okay, x term combine, subtracting them. So, 2x minus 6x, I have negative 4x. So, minus 2y minus a negative 4y. So, we have plus 2y. 1 minus 3, we have minus 2. And there is a common factor. No? So, I have to apply factoring because I have to divide this result later with either kini or this one. Okay? So, negative 2 is common. So, I can start with x term, positive. 2x, correct? Minus y. Now, since this is a negative, so the sign of the terms will be changed to their opposite. Now, so from minus, it becomes plus. Plus becomes minus, minus becomes plus. Okay? So, this is now the difference of the two partial derivative. If I'm going to compare with the two coefficient, so you have already the idea what would be your divisor, whether it is at n, this is your n, or is at m. So, this factor is exactly the same as this. So, if I'm going to divide with n, then I cannot produce with purely x function. No, like this. So, it's not okay. So, you may not see this anymore at the same time, no? Because, if you divide with m, so certainly, you will arrive with a function in y, no? So, this is the difference, the numerator. My m is used as a divisor. So this is involving xy, and that is removed. So what is left is a function that is purely y. So this is okay to proceed finding the if. How to get the if? Or the integrating factor, which is denoted with v. By formula, it is equal to the exponential of the negative of the integral of the g sub y dy. So it is equal to the negative of the integral of, what is our g sub y? It is minus 2y, 2 over y, dy. Okay, so that makes the expression as plus. So I have 2, the dy over y, and by formula, that is equal to the exponential of 2 ln y. To simplify, so let this coefficient be 1. So himuha siya nga power of your y. So that is equivalent to this, which can be simplified being equal to y squared. Kung doon na gani coefficient sa imong ln and this is e, so have it as a power before you can give the simplified form. This is free from e, and this is free from ln. Na? Okay. Now, that if, or that integrating factor, denoted with v, will be multiplied to the given dA, and our purpose there is to convert it into an exact dA. Okay? This one. Original equation multiplied with y squared being the if, so akong i-distribute, so this is now the terms produced. Then I have to retest for exactness. This is my m, and this is my n. Okay, what are you going to do with your m? Differentiate your m partially with y. And what is the derivative of your m partially with y? This is 6xy squared, correct? This is 4y cubed, and this is 3y squared. When you differentiate your n partially with respect to x, that is also 6xy squared, and it exists. With respect to x, this is 1, so you have the 4y cubed. 3xy squared, this becomes 1, so 3y squared. So the two partial derivatives, so I try to save time, no, by writing it once, no. So makes, no, ang atong if nga gi-provide makes the new differential equation as exact. So what's the next? You can solve for the f. So this is now leading to the solution of our d. So with your f, no, so from the exact dA, so I can solve for f by integrating every term. Kani, mula natin nagsaon. So f is equal to m dx. This is m dx. So integrate partially with x, then you can include. Later, after you're done with integration, you can consider a function in y being your constant of integration. So this is the coefficient. I list it down, okay, as my integrand. So I integrate partially with x. So we have x squared over 2. So 2 is eliminated. So this is a constant. So I integrate a dx. No? So x is the result. So you can also provide x in the next term. Okay, because they are all constant term, no? Or a constant factor when you integrate the second and the third term. So x from this, x from this one. Okay? So plus the unknown function in y. Answer, but I have to wait for the value of the g sub y. Okay? So that's possible to identify if I have to integrate the second term here partially with respect to y. Okay? Have you noticed that all the terms are involving xy? So if they are involving xy, so for the second time I have to do the integration, these terms will also appear in the integral of this term, no? Provided that I arrive with a correct f dire. Okay, so this can be used for checking. Okay, so these are the terms coming from the coefficient of dy, no? So kini 3x squared y squared. Okay, did I copy correctly? Okay, so there I have all the terms. Integrate with y partially with a variable y. Cube over 3, so y cube. So 3 is eliminated. So fourth power over 4, so 4 is out. Okay? Cube again, because x is our constant. Correct? Okay, cube over 3. So xy cube. So, plus the unknown function involving, so ang ato akarong y is the variable of integration. We treat our x as constant. So, plus the unknown function involving x. Correct? Okay. Now, I'll be looking for a function in y. Dire. But there's none. A function in x, there's none. So, that would mean that the g of y and the f of y does not exist. Okay? So, that means that these are the terms in my f. Then by checking, so they are all x and they are common. So my f, I have to copy the terms and either A1 or A2. No? So my f is equal to this. No? So bisag asa, but do not duplicate, no? Because you only have to consider either A1 or A2. So, copying all the terms, then forget about this because the function in y and function in x are actually does not exist, no? So wala sila mo exist ato ang solution. Okay, so but f is equal to c, so we can have this as f, then we can replace our f by c, and this is our general solution. So far, no, ang atong na-apply are case 1 and case number 2. So in the next video, we have a continuation of this, no? So for now, no, so we have to stop until this part and try to it for the next tutorial video. So for now, thank you for watching, and again, I'm inviting you to subscribe, no, and share this channel to others, no. So who knows, this can be helpful also to them. Okay, so thank you and goodbye, no. So ayo.